the purpose of this little section is so we can have an example of something that's not a function. Okay. So circles, they are curves, but they are not functions. And when we start talking about function, it's good to have an example of something that is not. So that's why we are kind of talking about circles here. Okay, so let me ask you a question. If I give, do you know what a Cartesian plane is? The x, y. So you know, for coordinate system, rectangular coordinate. If I give you a point 2,5, you know how to plot that point. Yes. 2 represents the x and 5 the y and so on. Okay. Let me just say here recall. So if I ask you to plot 2,5, you know, the standard way that we do this is, and for this is it doesn't matter. So you know, normally what we do is we draw a pair of lines similar to like when we're talking about complex numbers. Just this time there is no real and imaginary axis. Okay, this x, this is y, and this is just a way of talking about a point. So what we do is, let me just say something about this. So what we are establishing here is what we call a coordinate system. Okay, what's a coordinate system? A coordinate system is a way to orient yourself. Okay, so just think of this board here. This is like a plane. And let's say that we want to give a name to every single dot. So I'm going to put a dot here. I want to give it a name. In other words, I want to differentiate that dot from this one, from this one, from this one. Okay? I want each of these guys to have a name. But to be able to do that, we need to have a reference system. For example, for the computer itself, typically is this point down here, like the lower left corner of the screen. This is what they call the origin. And why? Because this way now everything's going to be positive for us. Okay? The moment that you fix a point called the origin, the moment that you do that, then every other point receives a name. Okay? Well, so what I'm talking about here are rectangular coordinates. There are other type of coordinate system, like polar coordinates and other ways to orient yourself. Like when you study trigonometry, you learn about polar coordinates. Okay? All right. So we declare, we fix a point that we call the origin. Okay? And then we draw a pair of vertical lines, as you all know. The horizontal one, a pair of perpendicular lines. So the horizontal one is x, the vertical one is y, and then you know we put our distances here. Let's say that this is what we mean by 1, 2, 3, and so on. Okay, I'm gonna say 2,3. I don't want to go too far away. -2, etc. And then all of a sudden now every point has a name, because given any point on the screen here, I can project it down to the x-axis to get a number on the x, and project it to the y-axis in a perpendicular way to get a number on the y. And we make it a pair. Okay? And every point is uniquely represented by such a pair. So the point 2,3, that means x equal 2. So points have the form x, y. Okay? So x is 2. And y is 3. So we're talking about this guy. Okay? So from now on, everything that we're going to be doing is going to happen here on the xy plane. Okay? And we're going to be analyzing collections of points, which is what the graph of the function is. Okay? Just collection of points on the plane satisfying a certain property. Typically a certain equation. So we will get there. All right, so this is how you plot the point. So now another question arises. If I give you 2 points on the plane, we can always look at the line segment connecting the 2 points, right? And another question is, what's the middle? So given 2 points, how do you find the point between those two? In other words, the midpoint of the line segment. Okay? So if I give you another point, I don't know, let's say 4,5. I didn't want to go to 5, but I'm going to go to 5. Then let's say I give you 4,5. That's this other point over here. So the moment that you have 2 points, then you can talk about the line segment joining those two points. So it's 2,3. So 2 points determine a line segment. And another question to ask is, what is a midpoint? So for example, I don't know, I'm just gonna try to estimate more or less. Maybe it's, oops. Maybe somewhere in here. Let's say that this is M. So M here is what we call the midpoint. Okay, so it's going to have coordinates x, y. We want to be able to figure this out. Okay, we want to be able to find what's the x and the y of this point, which is the midpoint of the line segment when you're given 2 points. Okay, so that's the first question that we want to answer. The next question that we're going to answer is, how given 2 points, like this one, there is a line segment. Another question is, how long is this? So what is this distance? What's the measurement of this line segment? Okay, so as the distance between 2 points. Given 2 points, the distance is the length of the line segment joining. Okay, so how do you measure this? So there's a little formula that gives you this. That's called the distance formula. Let's discuss it, and then once we have understanding of the midpoint and distance formula, then we can talk about circles. Okay. All right. So let's address the midpoint question first. So the goal here, given 2. So I'm gonna do it in general. Okay. So given 2 points, let's say x1, y1, and x2, y2. These are 2 points in the plane. These are 2 arbitrary points. If you want, we can call this one P, and we can call this one Q. Okay? Given 2 points P and Q, what is the midpoint of the line segment connecting the two? So find the coordinates of the midpoint. Let's call it M. Let's say xm, ym. Just for M for midpoint. Okay. It has coordinates x, y. We want to know what these guys are. So find the coordinates of the midpoint M of the line segment. PQ. Okay? PQ or QP, doesn't matter. When you talk about line segment, it doesn't matter what's the starting point, what's the finish, and what's the ending point. When you talk about vector, that's a different story. But line segment, that's okay. All right, so that's the problem that we want to figure out. Okay? All right, so let's see. Let's draw a picture and let's see what this is gonna give us. So here is x, here is y. I mean, these x and y's, they could be positive, negative. For the sake of argument, let's assume they are positive, so we have an idea of the picture. Okay, but it doesn't matter if some of them are negative. Okay, so let's say that x1 is somewhere in here, and y1 is somewhere in here. In other words, here is our point P, and then let's say that x2 is somewhere in here, and y2 is somewhere in here. Here is a point Q. So our job is to look at and to figure out a formula. Given this data, we want to be able to figure out a formula for the midpoint. In other words, we draw a line segment. And then go away. And let me just estimate. Here is where M should be, more or less. So we want to be able to figure out the coordinates of this. So what do we know about M? Because it's the midpoint, what we know for sure is that this side equals this side, right? That's what we know, because that's what it means to be a midpoint. It splits this line segment in half. Yes? All right, so any ideas? How can we find M knowing P and Q? What can we do here? Yes?
Well, if you take, if you have the 2 x coordinates for each, and then you add the 2 y, and divide by 2, and then add the 2 y coordinates for each, and divide by 2, then you have like half the distance between each of them, and they correspond, and you should create a midpoint.
So why would that work?
Well, like if you look at y2 and y1, if we're finding halfway,
Now, how do you find well halfway?
Well, you add them up and divide by 2.
So you are assuming, so you're telling me that halfway here and halfway here
No. Y2 and
is
Y4.
gonna make
Yeah.
halfway over there. So that's a strong claim. So we need to kind of justify that. But that's a good way to think about it. Good. So what your classmate is saying is, okay, if you want to find the midpoint of a diagonal distance like this, what you can do is find the midpoint of the vertical distance, find the midpoint of the horizontal distance, and then that should give you the midpoint here. But this needs to be verified. I mean, for example, I'm not 100% sure that this is always the case. Okay, so let's see. Can we see that? Is that always the case? So when you have a diagonal line, I mean, I know it's always the case, but how do we see? How do we justify it nicely? When you have the diagonal line, if you use a rectangle, diagonal line, this could be the diagonal of a rectangle. Yeah, but then we need to use all the theorems that the diagonals of a rectangle, they are equal and they intersect at the midpoint of the diagonals, which is also the midpoint of the rectangle. That's too much. So let's just do the classic stuff, which is basically is similar to what you are describing, but we need to prove it. So we're gonna do a little construction, okay? So I'm gonna do 2 triangles. From here, we can do this little triangle. So everybody see that? This little right triangle. And similarly, using Q, I can do this little right triangle. So there are 2 triangles here. Okay? Okay, so we have 2 triangles. So we have the yellow triangle and we have the blue triangle. Yes? I claim that these 2 triangles are equal. Who can justify this to me? Yes.
Hypothenuses are equal.
Good. I mean, that's not enough, right? So, for example, I can give you this, and this. Sorry. So I can give you that. Then let's see. I want the hypotenuse to be equal. Okay, so let's say that this is 7, right? I could do the following. To make 7 here. Point is that I can change this angle, so I can tilt this a little bit more than the perpendicular. I have 2 right triangles, they both have 7 hypotenuse, but they're certainly not the same, right? Because this angle is the same as this. So having said hypotenuse is not enough, but that's a good start. So what else can we argue here? Yes?
You could say they're the same angle, that PM, I'd say, same angle.
Very good. So this angle over here is the same as this one. Why?
Because on the same line. No.
So if I do this angle and this one, they are not the same. So
Oh, it's parallel.
good. So remember, you guys did geometry, right? Yes? So when you have notice that this line over here, the red one, and the blue one, if I were to extend this, these are parallel lines. How do we know these are parallel lines? Because they are perpendicular to this. When 2 lines are perpendicular to a common line, then they are parallel. Okay? So these 2 lines are parallel. So these angles, this is a transversal. These angles are called corresponding angles. So they match. Okay? So this angle is the same as this one. And therefore, what's the sum of the interior angles of a triangle? What is it? 180. Because you already have these 2, and these 2 are equal. What can you say about these 2 guys? They must be the same, right? Because the sum is 180 for both of them. If 2 are equal, then the third one, they have to be the same. So, moral of the story. We have this side, which is the same, and these 2 angles, which are equal for both triangles. This is the angle-side angle criterion. There are 3 ways to show that 2 triangles are equal. If they have one side in common, and then the angles that are adjacent. If these angles are equal for both triangles, that's the angle side angle criterion. Then the triangles are equal. The other one is if two sides are equal and the angle in between, okay, that's the side angle side criterion. Then the triangles are equal. And then the other one is, well, if the three sides are the same. I mean, if the three sides of the triangles are equal, this is the side. Do you remember these things? Okay. So in this case, we're using the angle side angle criterion. Okay. So these two triangles are equal. If these two triangles are equal, in particular, these little sides are equal. Okay. And this one over here are equal. So let's exploit that. Let's exploit that information. How much is this? By the way, remember that M, this is Xm, and this one over here is Ym. Okay, so how much is this?
Xm minus X1.
Good. Let me write it down here. So this one over here is Xm minus X1. Yes? Therefore, and okay, and how much is this? X2 minus Xn. Good. Okay, good. Now, similarly, how much? Let's see, this one over here. Okay, this one, I'm gonna put it here. Okay, so that doesn't get too messed up. How much is this? This is Ym minus Y1. And then how much is this? That's Y2 minus Y. Is everybody following what we're doing? Okay, now let's use the fact that the two triangles are equal. So since the two triangles are equal, so remember, in math, when you say something, you need to justify. You cannot just tell me, oh, find midpoint here, then you get your midpoint. Yeah, tell me why that works, right? That's what we're doing, okay? So we are proving this statement. Okay, so since the two triangles are equal, because by the angle side angle criterion, then there are some things that we can say. In particular, we can say that this side over here is the same as this one. I could put a letter here and then we can label it. Let me do it. So I'm gonna call this one, I don't know, let's call it O, and let's call this one O prime. So then we get that O, we get the PO, okay, the side PO equals the side MO prime. Okay, it corresponds to each other. And we also have that MO equals QO prime. Does everybody understand this? Do you understand what I'm saying? This side equals this one, this side equals this one, because the two triangles are the same. Yes? If you take this triangle and you translate it, and you overlap it here, they're going to overlap nicely. Hypotenuse here, this angle with this angle, this one with this one. So this side, MO prime overlaps with PO, QO prime overlaps with MO. So they are the same, okay? But we have formulas for those. What's PO equal to? Look at the picture, it's in the picture. What's PO equal to?
Xm minus X1.
That's Xm minus X1. What's MO prime equal to? Don't look at me, look at the picture. What's MO prime equal to? That's X2 minus Xm. X2 minus Xm. And now our job is to find Xm. So solving for Xm, what do we get? We get 2 times Xm equals X1 plus X2. Therefore, Xm is, as your classmate pointed out, the average of the x's, right? X1 plus X2 over 2. Do you understand this? All right. So then similarly, we can then argue the other one. So MO is equal to QO prime. So by looking at the picture, we can see that MO is what? What is MO? So that's YM minus Y1. So that has to be the same thing as QO prime, which is Y2 minus YM. Okay, so solving here, we get 2 times YM is Y1 plus Y2. So YM is Y1 plus Y2 over 2. Okay, so moral of the story, if you're given 2 points, now it's pretty straightforward to figure out the coordinates of the midpoint of the line segment defined by the 2. The x value is given by the average of the x's, the y value is given by the average of the y. Okay, so theorem. The midpoint M of x1, y1 and x2, y2 is given by x1 plus x2 over 2, y1, y2 over 2. That's what we call the midpoint formula. Okay, any questions for this? All right, so let's see. Let's go ahead and let's find M here. Let's find the midpoint of these two guys. So 2,3, 4,5. So example. So find the midpoint. And then let's do 2,3 and 4,5. And then let's do negative 1, 1/2 and 2, negative 7. Okay, so how do we do the first one? How do we find the midpoint? What do we need to do? So you add the x's divided by 2, add the y's divided by 2. There's really nothing fancy happening here. Okay? So what is it? So that's 6 over 2, so that's 3. 8 over 2, that's 4. So the point 3,4 is a midpoint. In other words, over here, this guy is 3,4. Okay? So, okay? All right. So go ahead and tell me the midpoint of the next one.
Can we use decimals?
No, the exact. Well, I'm giving you the question, the answer, the question with fractions, so I want the answer with fractions. Remember, decimals are not good to graph. Okay. For example, how do you graph 1/3, 1 over 3? If you write as a decimal, that's 0.3333333 non-stop. How do you graph that? If you think about it as a decimal, you're not going to be, to find that exactly, that's a pain. But as a fraction, it's really easy. 1/3, that means you have your distance here, your unit distance, split into 3 equal pieces, pick one of those. That's it. Okay? That's why fractions are, actually mixed numbers are good because of this. If I ask you to graph, I don't know, 57 over 8. How do you graph this? So what you should do is change it to a mixed number. So what is this? So that's 7, 1, 8, right? Because this is 56 plus 1. So that's 7, 1, 8. So what you do is you have your unit length here. Let's say that somewhere in here you have, this is 7, this is 8. So you go all the way up to 7, and then this unit length, you split it into 8 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, and then you pick 1. And that's how you plot. Okay, so that's why mixed numbers are good. Because if you write as a decimal, I don't know, maybe in this case you will get something nice. You may be able to do it, but if you get a repeating decimal, then how do you find a spot in the number line? So that's why it's good to have fractions, and even more in these things that typically you want to plot the point, for example. Okay, so what's the midpoint in here?
1/2 comma -2.
What is it?
1/2 comma -3 1/4.
So 1/2 comma
-3.
-3 1/4.
Yeah.
All right. So let's see. So this is gonna be -1 plus 2 over 2, and then this is gonna be 1/2 plus -7 over 2. Computing this, we get 1/2, and then for this one, what do we have? So let's see, I'm gonna multiply top and bottom by 2. If you multiply top and bottom by 2, you're gonna get 1 minus 14, that's a -13 over 4. So that's -13 over 4. And that's the same thing as this, because when you do 3 times 4, that's 12 plus 1, that's 13. So that's how you go from mixed to, if you wanna go from here to here, what you do is 7 times 8 plus 1, and then you keep the same denominator. Okay, that's how you go back. And 3 times 4 plus 1, that's 13. Good. All right. Questions? All right, good. So this is how we find midpoint. Now the next question that we wanted to address is distance. How do we find the distance between the 2 points? So the distance formula. And the goal here is given 2 points. So given 2 points, x1, y1, and q being x2, y2, find the distance between them. Which means the length of the line segment connecting the 2, okay? All right, so that's our goal. That's what we want to do. So let's see. Once again, let's do a picture. Again, I imagine that most of you already know this, but I want to make sure that you understand why this is true. So that's the whole point. Okay, so then let's say x2, y2, they are over here. So this is Q, and now what we are interested in is in this line segment PQ, and we want to know its length. Okay, let's call it D. We want to know what this is. Okay, you are eager to say it, so go for it. So what do we do?
So if you make it as a triangle from P as it intersects with line Q,
very good.
Whatever you want to call that point, then you have a triangle, and then D is the hypotenuse of the right triangle. So then it's x2 minus x1 squared plus y2 minus y1 squared equals d squared. So you take the square root of
and then you solve. Very good. So in other words, the distance formula is just Pythagorean theory, right? And so this has been popping around in the homework and so on. So in case that you don't remember what is Pythagorean theorem says, so we do the construction right here. Okay, let's study this by steps. We do the construction that your classmate pointed out. Just stand this perpendicular over here, so we get a right triangle. Okay, and then the distance that, which is d, what we want is the hypotenuse of that triangle. And then if we can figure out what are the lengths of the triangle, then we can use Pythagorean theorem to find d. Okay, and indeed we can, because what is this leg? That's x2 minus x1. And what is this leg? Where is it? That's y2 minus y1. So we are good to go. So very good. So using Pythagorean theorem, using Pythagorean theorem, we have the following. So let's see, let's first write it with the letters of the triangle. Pythagorean theorem says that the sum of the squares of the leg equals the square of the hypotenuse. This is only true for a right triangle. In other words, PO squared plus QO squared, that's going to be equal to PQ squared. Do you understand this? It's Pythagorean theorem. So actually, I'm going to write it the other way around. So PQ is D, so that means that D squared equals PO, that's x2 minus x1 squared, plus QO, that's y2 minus y1 squared. And because we are after D, what we do is we take square root. This time we don't worry about the plus or minus because we're talking about a distance, and distance is always positive. Okay? Good. And this right here is what we call the distance formula. Okay, so in other words, to find the distance between 2 points, all you have to do is subtract the x's and square it, subtract the y's and square it, add them, and then take square root. Okay? Good. Questions? All right, so I guess let's do one little example. Find the distance. So example. Find the distance between 1,5 and 5,8. Okay, so we have a formula. So all we have to do is plug in. So the distance between these points, that distance is going to be the square root of, so difference of the x's here, it doesn't really matter. So I understand it says here x2 minus x1 and so on, but remember, notice that we are squaring this. If I were to write x1 minus x2, what would be the difference between x1 minus x2 and x2 minus x1? What's the difference between those two quantities? The sign. One is positive, the other one is negative. Yes? But what are we doing anyways? We're squaring, so the sign doesn't really matter. Okay? So here it doesn't matter who you call point 1, who you call point 2. Just subtract the x's and square it. Subtract the y's and square it. Do you understand what I'm saying? It's irrelevant who is x2 and who is x1. In other words, I'm going to just do 1 minus 5 squared plus 5 minus 8 squared. Okay? You subtract the x's, subtract the y's, and then square. So that's going to be negative 4 squared, that's a 16. And then negative 3 squared, that's a 9. So we get square root of 25, which is 5. So the distance between those 2 points is 5 units, whatever the units are. It really depends what scale you have going on in your coordinate system. So, what units you're using to measure, etc. Okay, questions? So we know how to find midpoint, we know how to find distance. Now this can be used to put in problems that involve circles. So now let's talk about circles. So circles. I guess before we go on, everybody here knows what a circle is. At least when you look at it, you can identify, right? Now, our job is to identify its equation. So we want to be able to describe a circle mathematically. In other words, via an equation. We want to be able to look at a circle and say the equation of the circle is whatever, or to look at an equation and say this is the equation of a circle. Moreover, here is a circle, and graph it. You understand? So that's what we want to do now. So we need a definition for a circle. You cannot just tell me, oh, something that's round. Okay, so we need a definition to work with it so we can come up with the equation and all that business. So who can give me a definition for a circle? Let's see, what's the defining property of a circle? What's important about a circle? What makes two circles be different from each other?
The radius.
A radius, right? That's a very important quantity. Now I will ask you what's the radius, but the radius, right? That's an important quantity. What else is important about a circle? The center. Good. So what does the center tell us about the circle?
It's like the center and any point on the circle is always the same.
Yes, so tell me the definition, but what does the center tell you about the circle?
Where it is in the coordinate book.
It's like the position of where the circle is, right? Like if you don't care about the position, then the center is really not that meaningful, right? Then the radius is really all you care about. A circle radius 3, then, you know, I don't know, this guy, but it could be also this guy or this guy. If you don't care about the position, then the radius is all you need. But when we have a coordinate system, typically position is important. Like this circle is not going to be the same as this circle for us because they are in different places. You understand this? So we need both the center. The center is information about the position of the circle, and the radius, which kind of defines how the circle looks like. Okay, like the size of the circle, something like that. Good. So using those two ideas, then how can we define a circle? So what is it?
The distance between the center and any point on the circle is the same.
Good. So a circle is a collection of points in the plane. So at the distance of all of these points, with a fixed point called the center is always the same. So it's all points that are equidistant from a fixed point. Equi means same. Okay? So that's what a circle is. Good. And we're going to take advantage of that to find the equation. So definition, a circle is a collection of points in the plane that are equidistant. So that means same distance. Equidistant, should I say from or to? I want to say equidistant to or from a fixed point. Now I'm not sure if I should say to or from. What's the right preposition? From? Okay. Equidistant from, that are equidistant from a fixed point called, now this fixed point is special. It's not a point on the circle. You understand this? This is not on the circle. But it's special. It's called the center. Called the center. And then, because it's a collection of all those points that are equidistant from this special point, then the special point deserves a name. That distance that's the same, no matter where you are, also deserves a name. We call it the radius, right? This distance is called radius. Okay? That's what a circle is. That's the definition. Now, we want from here to be able to figure out formula, of course. So, you know the little tool, the compass, which is the one that you use to draw a circle, and that's exactly what you do, right? So you fix the center, then you fix the distance, and then you just let the compass move itself, and it turns out that when you move it around, you're gonna obtain what we call a circle. Okay? So this is nice, but this really doesn't give us much. So we want an equation. So we want to write down the equation of a circle. So let's use the definition. So suppose that you have a point on a circle. So first of all, let h comma k be the center. And let x comma y be a point. On a circle, we center h comma k and radius, typically we use the letter r. And radius r, because radius is distance, it has to be greater than 0. Okay? So what we want is we want to write down an equation that this point must satisfy. Okay? But remember, the center, you know what it is. So h and k, these are known quantities. The radius, you know what it is. It's a known quantity. You want to be able to figure out an equation that x and y is going to satisfy. Okay? And vice versa. So if a point satisfies the equation that we write, that will be a point on the circle. And if you have a point on the circle, it will satisfy the equation that we're about to write. If we do that, then that would be an alternative description of what a circle is, and it's better to do algebra with it. Because with this, we cannot do much algebra. You can do some geometry here, but you cannot do algebra. So that's why we want the equation. Okay, so what can we say now? We have this point x comma y, which is on the circle. So what can we say about this point? What do we know for sure about this point? What's its distance from the center? R. So what we can say for sure is that the distance between x comma y and the center equals R. Yes? I mean, that's what it means to be a point on the circle. Its distance from the center is a radius. But now we have a formula for the left side. What's the formula that we have here?
Square root
This is the square root of,
x minus k squared.
so x minus a squared. Remember, subtract the x's and square it, subtract the y's and square it. Yes? And then, of course, it's okay, but it's not nice. We want to get rid of the square root. So what do we do to get rid of the square root? We square both sides. So we end up with x minus a squared plus y minus k squared. This is equal to r squared. And this is what we call the equation of a circle. So this is the equation of a circle with center h comma k and radius r. So this means that any point on this circle will satisfy this equation. So the x and the y, we put it here and we'll make this a true statement. And also the other way around. Any pair of x and y that satisfy this equation corresponds to be a point on this circle. Okay? So now we have an algebraic description of what a circle is. And the good thing about this is that just by looking at the equation, you can easily read off the center, the radius, and so on. So let's do a couple of examples like this. I'll give you the equation, you need to tell me the center, you need to tell me the radius. Okay? And then let's practice graphing, and then this is called the standard form of the circle. There's another form, which is the general form. And from the general form, you need to be able to recognize that you have a circle, and then tell me center, radius, and all that business. Okay? So that's the type of exercises that we will do. So let's see. Before I go there, are there any questions on this? Good. So samples. Let's see. First, find center, radius, and graph. So find center, the radius, and sketch the circle. Okay, so for the first one, let's see, A, let's do x minus 2 squared plus y plus 3 squared equals 25. And then here, let's do x squared plus y squared equals 1. Part B, that's a very important circle in trigonometry. All right, so let's see. So first of all, you have to be able to look at something like this and recognize that you are looking at a circle. Okay? So you need to recognize that this is the equation of a circle. That's the first thing. And second, once you recognize this, you have to be able to tell me two things immediately. You need to be able to tell me the center, and you need to be able to tell me the radius. But let's see, what's the center of the circle? What is it? 2 comma negative 3. Very good. Does everybody understand this? So look at the formula. The formula is x minus h, and here y minus k. H and k are the coordinates. But because of the negative here, it means that whatever number you are actually looking at, the actual value has the opposite sign. Okay? So if you're looking at a negative 2 here, then that means your h is 2. If you're looking at a positive 3 here, that means your k is negative 3. Because you can write this as minus 3. Do you understand what I'm saying? So you just change the sign. Okay? So just be careful because typically this is a point where students can make mistakes. Okay, so you got your center. What's the radius? The radius is 5. Very good. In other words, the radius is the square root of whatever number you have in here. Do you understand this? Good. How about B? Now we're going to graph it, but how about B? What's the center?
0.
So in this case, if there is nothing going on around X or Y, then that means that both H and K are 0. Or if you have one variable by itself squared, that just means that the corresponding value with the H or K is going to be 0. Okay, so you can think of this as X minus 0 squared, and think of this as Y minus 0 squared. Okay, in other words, the center here is the origin. And what's the radius?
1.
And the radius is 1. This circle is very important in trigonometry. This is called the unit circle. Okay? In fact, this is used to define the trigonometric functions sine and cosine in general. Okay. Questions? All right. So I guess let's just do one little example practicing how to graph the circle. So the moment that we know the center and the radius, we are able to sketch the circle. Who can describe to me a procedure? How can we go ahead and graph the circle corresponding to that equation? What do we do? Yes.
You plot the center and then you go 5 up, 5 down, 5 right, 5 left.
Very good. So, basically to draw the circle, there are like 4 key points that you need, right? So once you have the center, then you find the point that's going all the way to the top, all the way down, the way to the right, all the way to the left. You have your 4 points, and then do your best to do a circular shape because we don't have a compass right now here. But as long as you show me those 4 points, then that's good enough. Okay, and a reasonable shape, like then don't do this. Okay. So let's see. I'm gonna try to be picky with this one. More. Let's see, that's 2 comma negative 3. So that's 1, that's 2, 1, 2, 3. So that's where the center is. Okay. Now, because the radius is 5, that means that my circle is going to be around a distance of 5 from this point. So let's find 4 of those. So going all the way to the top 5 units, that will be 1, 2. So here is one vertex. Then going 5 units to the right, that's 3, 4, 5, 6, 7. That's another one. Then 1, 2, 3, 4, 5. That's another one. And then you go 5 down. So 1, 2, 3, 4, 5. That's another one. Okay, so I'm gonna do my best. Let's see. But we're gonna be a little bit more precise now in a second. What I mean by that is every time that you do a graph, okay, every time that you show me a picture, if there are any intercepts, the word intercept means points at which you cross any of the axes. If possible, you need to find it. Okay? So to really see if this picture is accurate, there are some points that you need to tell me, right? There are 4 intercepts that you need to tell me. So you need to tell me these guys. How do we call these points? X-intercepts. I mean, they are intercepts and they are crossing the x-axis, so they're called x-intercepts. And these points, how do we call them? Y-intercepts. Okay? All right, so let's find them. And the moment that you give me those points, then even if the picture is super messy, then with those it's kind of already fixed what the circle is. Okay? So let's find the intercepts. That's this is a good application of what we have discussed about quadratic equation. So the intercepts. Okay, so question. Given, and let me write down the equation. What was the equation? X minus 2 squared plus y plus 3 squared equals 25. How do we find intercepts? For example, the x, let's focus on the x-intercept. X-intercept. How, in general, given any picture, how do we find an x-intercept?
When x is equal to 0, because that's when it's on the x-axis.
Think about it again.
Wait, sorry.
Y is equal to 0, right? So remember, to find an x-intercept, you're looking for points on the graph, but they are on the x-axis as well. What does every point on the x-axis have in common? What do they all have in common? They are y is 0. That's the only thing that they have in common, like everybody. Yes? So how do you know that a point is on the x-axis? The y value is 0. So if you want to find them, just go to your equation, put y equals to 0, and so forth. Okay? So to find the x-intercepts here, we need to put y equals 0. So in other words, we need to solve this equation. X minus 2 squared plus 0 plus 3 squared equals 25. Okay? Let's solve it. So what is this? So you get 9, move it to the other side, that's a 16, right? So then x minus 2 is what? What's x minus 2? Plus or minus 4. Remember, square root method, okay? Plus or minus 4. So we have two little equations here. X minus 2 is 4, or x minus 2 is negative 4. So what do we get here? 6 or negative 2. So, here I was a little bit off, so let's fix it. So let's find them, and then I'm going to redraw my circle, okay? So now we know we need to go through 6. We need to go through negative 2, okay? We need to go through those points. Now we are getting more precise. So let's find now the y-intercepts. So on a similar way, how do you find a y-intercept of a graph? You make x equal to 0, because this is a point that's on the y-axis, right? So what does every point on the y-axis have in common? The x value is 0. So you go to your equation, and you put x equals 0. So setting x equal to 0, we obtain the following. So that would mean that y plus 3 squared equals, so as a 4, moving to the other side, you get 21. So we get y plus 3 is plus or minus square root of 21. So two equations here. Y plus 3 is square root of 21, or y plus 3 is negative square root of 21. So negative 3 plus square root of 21, and negative 3 minus square root of 21. Okay? So let's see. Square root of 21, what is this? This is between 4 and 5. So this is 4 point something. So that means it's going to be 1 point something. Okay? So this is about 1 point something. So as somewhere in here. Okay? Somewhere in there. And then the other one, negative 3 minus 21, that's going to be negative 7 point something. Okay? So, I mean, you can find it in your calculator, but just to have an idea, that's going to be somewhere in here. Okay? So now we are in better shape to draw a circle. Now we need to go through all these points. Maybe in a worse shape. I think the circle looks worse than the first one that I drew. Anyways,
Where the intercepts are.
now we know the intercepts. This one, I think it was. It's okay. All right. Do you understand how to do this? So in general, every time that you graph a function later on, we'll talk about functions. If an intercept shows up in the graph, you need to find it. Okay? If you're crossing the y-intercept, the y-axis, you need to find it. If you're crossing the x-axis, you need to find it. Okay? And remember that I already gave you the strategy. To find x-intercept, make y equal to 0. To find y-intercept, make x equal to 0. Okay? All right. Questions? And for this one, I guess for completing, this one is straightforward, right? So it's the unit circle. We centered the origin, so we just do 1, -1, 1, -1, and sketch. Okay? Okay, so that's that. Now, again, so if you are given this, you should be able to give this information. Also, do you think that if you look at a picture and you're given the center, you can find the required information to write the equation? Should be clear, right? I have to do it. So now, let me, to close this, let's see as another example, see number 2. Now find center and radius. Let us not draw anymore because drawing is the same all the time anyways. But let's practice finding center and radius. But this time I'm gonna give you a circle, what we call general form. So this equation that we have here is what we call the standard form. And this is the preferred one because you have all the needed information is right there in front of your eyes. You can see a center, you can see a radius, okay? From this equation, you can read it straight from there. Now, as you understand, I could go ahead, I could expand this, right? I could expand this square, combine like terms and all of that, and then you will obtain an expression like this. Okay, you will obtain an expression like this. And now the problem with this is that now here it's not obvious what the center is, what the radius is. So we need to do some work to be able to find. Do you understand the problem? Okay. So that's the whole point. So how do we do this? So the idea is that we kind of want to backtrack this process. In other words, we want to write this in the standard form because once you write it in standard form, you can easily see the radius and the center. Okay. And what technique do you think we're going to use to go back to the previous form? We complete the square. Okay? That's why we needed to discuss completing the square. So here we need to complete the square on 2 variables. We need to complete square on x and complete squares on y. Sometimes. Like in this case, we don't need to complete it on y because there is no linear term. You complete the square if there is a linear term. Okay? Because you want to have something squared. Here we already have y squared, so there's nothing to do with that. So we keep it like that because there is no y term. Just with y. So first thing that we're going to do is we get rid of that -8. Push it to the other side. Now this one is already as it is. You can think of this as y minus 0 squared. Okay, so that's fine. Now we just need to complete the square. So we need to figure out what to put in here so that this becomes the perfect square. So what is it? So we need a 4. Everybody remember how to find this 4? Take this guy, divide it by 2, and square it. Okay? So we add 4 here, but if I add it there, what else do I need to do? Add it to the other side. So now this becomes x plus 2 squared plus y squared equals 12. Do you understand this? So now we have this in standard form. So we are ready to write down center and radius. So what's the center? -2,0. What's the radius?
What? Wait, no. Square root of 12.
Square root of 12, which is? So you can think of this as 4 times 3.
So 2 times 3.
So 2 square root. Do you understand this?
Yeah.
Let me give you one more. Now you try this one. So let's see. X squared minus 6x plus y squared plus ay equals 3. Notice that this time there is a linear y term and a linear x term. So that means you need to complete the square on both variables. Okay? So you need to do this process twice, but you can do it at the same time. So, okay, we have 5 minutes left, so let's just do it together. Otherwise, we'll waste time. So does everybody understand that we need to complete the square on both variables? Okay, so do this. I'm gonna leave a space. Leave a space, and we already have the 3 on the other side. So let's see. Let's focus on x. What do we need here? What do we need on this space to complete the square for x? 9. Is everyone okay? So remember, let me just put it here. That's take the -6, and what do we do to it? Divide by 2 and square. Okay? So that becomes -3 squared, which is 9. That's what it's coming from. So if we put 9 in there, we also need to put it on the other side. Okay? Now let's go to the y part and repeat. What do we need? 16. Very good. And we need to add it to both sides. Again, that's the 8. What do we do? Divide by 2 and square it. Give you 16. Okay. So now, what happens to this piece? X squared minus 6x plus 9.
X minus 3 squared.
That becomes x minus 3 squared plus, what happens to this piece? Y plus 4 squared. Good. Equals, then what do we have here? 12 plus 16 is 28. All right, so now this is in standard form. We are ready to write down center and radius. What's the center? 3, -4. What's the radius? So square root of 28, which is 2 square root of 7. 28 is 4 times 7. Okay, good. Any questions? No? Okay, let me just ask you. We don't have time to do it, but let's say that I give you 2 points and I ask you to find the equation of a circle whose diameter has those points as endpoints. In other words, you have a circle, and then I'm giving you this point and this. So remember, to write the equation, what do you need? Center and radius. How do you find the center? That's a midpoint, so you use midpoint formula. How do you find the radius? Distance formula and divide by 2. Okay? All right.